All right. So let's continue from where we stopped in our last class. So, in the last class, we're taking questions on motion. And today we'll continue from where we stopped and move on to projectile motion. Now, let's see. In the last class, we stopped at question 3, right? Now, question 4, we're going to be solving just relevant questions, right? Question 4 says the motion of the moving skin of a talking drum can rightly be described as dash. Now, what's the answer to that? It says the motion of the moving skin of a talking drum can rightly be described as dash. Now, what's the answer? The answer is what? Random motion. That's question 4. The answer is what? Random motion. Now, why is it random motion? It is random motion because the skin of the talking drum vibrates when it is being hit. You know what a talking drum is? This is a talking drum, something like this. It's usually used by the Yoruba people. Then it has this curved stick that is being used to hit it. So as you hit the drum, even your normal drum, whether talking drum or not, the drum itself vibrates, and that's random, right? That zigzag vibratory motion is called random motion. So that's the answer to that. Now, next question is question 5. Question 5 says, what is the motion of a particle whose motion, what is the acceleration rather, of a particle whose motion is graphically displayed in the above figure? So they say, what is the acceleration? Now, I told you what a distance time graph is, right? We have distance time graph. Now, acceleration, I mean, this is a velocity time graph, not a distance time graph. Velocity time graph. Now, acceleration is change in velocity with time. Is that correct? Acceleration is the change in velocity with respect to time. So that means if you can check change in velocity over time, that would be acceleration. So that means the slope of this graph will give you the acceleration. So then, let's move on to get the acceleration. Okay? Let's move on to get the acceleration. Now, unfortunately, this particular graph is not very clear, so I will not be able to get it exactly, but I'll give you the idea of what you have to do. Now, this is the velocity time graph. Okay? So this is the velocity time graph. Now in the velocity time graph, I have two. Okay, no, I'm not doing it exactly well. Started from around here. All right. So I have 2, 4, 6, 8, and 10. And then here we have 2, 4, 6, 8, and also 10. All right. Okay. So to get the acceleration, it's going to be change in velocity with respect to time. Now, like I said, I can't really pinpoint the exact location because this graph is not really clear to me. So this is what you do. You draw 2 points, you get the slope of the graph. Then let's say, for example, 8. Now I can't really see where the points are. So let's say you trace to where 8 is, you get the slope. All right. So I'm tracing from 4 to probably 2 and from 8 to 8. So acceleration is changing velocity over time. And if you look at it, that is even the slope of this graph. A change in velocity will be 8 minus what? Minus 4. 8 minus 4. That will be 8 minus 4 over change in time will be what? 8 minus 2. 8 minus 2. So that will give me 8 minus 4 is 4 divided by 8 minus 2 is 6. So let me do that on my hand calculator right here. 8 minus 4 is 4. So I have 4 divided by 6. You can cross-check with me on your calculator. So 4 divided by 6 is 0.6666. Okay, that rhymes with option A. 0.666, which is 0.67. And that's how you look for the acceleration. You know, acceleration is changing velocity over time. So I just did a rough trace here. So from 4, I traced to the graph, right? From 4, I traced to the graph. And then I saw like 4 here met with 2 on the x-axis. Then I traced 8 and 8 met with 8 here. So acceleration is changing velocity, which is the x-axis, which is 8 minus 2 over, sorry, on the y-axis, which is 8 minus 2 over time, changing time, which is from 2 to 6, which is 6. Like from 2 to 6 is 6. Or to know, you can just say 8 minus 2. So that's the answer to that question. So next question is question 7. Question 7, right? Now it says a body falls freely. Says a body falls freely under gravity. Now, for a body to fall freely under gravity, that means initial velocity is 0. I've explained. That means the body was at rest. So it falls freely under gravity from a height of 40 meters. From a height of 40 meters, I think we will need to draw so you understand it. It falls freely under gravity from a height of 40 meters. Let's say this is the height of 40 meters. From here down to here is 40 meters. So from a height of 40 meters to the top of a platform, 0.8 meters above the ground. So let's say this is the ground and this platform is 0.8 meters above the ground. So a body, let's draw the body in red. So this is a body falling through this height. So it is falling down through this height of 40 meters. Then it lands on a platform. So that means what will be the total distance covered? Now, what will be the total distance covered by that body? Because the body will not get to the ground. From the top to the ground is 40. But then it's falling on this platform. So that means the total distance it will cover will be this point, right? Which will be 40 minus 0.8. 40 minus 0.8. And 40 minus 0.8, let's do that. 40 minus 0.8. 40 minus 0.8 will give me 39.2. So that means the actual distance that is going to be covered, or should I be doing it here? Just let me be doing it on my calculator here so you can see what I'm doing. So let's get my calculator up. So right here, let's get my calculator up. So, like I said, I did 40 minus 0.8. You can see it gives 39.2 because now from the top to the bottom is 40. But unfortunately, the body is not falling through that 40. It is falling on top of a platform. So that means you subtract 0.8 because it did not fall through the distance of 0.8, which will be 39.2. So that means that the actual distance covered by the body is what? 39.2. So having said that, distance is 39.2. Let's go on with our solving. Right, distance is what? 39.2. Then its velocity on reaching the platform is that. So velocity on reaching the platform is what we are looking for. Now, a body falls, we've gotten all the parameters. Like I've always said, when you're solving physics problem, always ensure that you write out your parameters. Even if you don't know what to do, write out your parameters. It could help you in saying something. You may notice an equation that will help you. So yeah, we have a body falling from rest, which means its initial as velocity is 0. Then, did I write final velocity as 0 now? We're looking for the final velocity. We don't know. But we know it is falling for rest, right? So for a body to be falling down, we've already said if you are falling down, you are falling with the aid of what? Of gravity. If you are falling down freely. So your acceleration will be positive of what? G, right? Because you're not going against gravity. That's why an object falling down falls down easily. That's why in physics we say falling freely as far as you are falling under gravity. So that means the acceleration is positive, which is 9.8 meters per second squared. Now, the distance covered, like we've proved, is 39.2. Now, are we saying something? Are we saying something? Because I'm already saying something, but I'll just give you some time I'll give you some time to use to check to see if you are seeing what I see. All right. So now the equation to use is v squared is equal to u squared, right? Plus 2as. Remember, it is paramount that you know your equations of motion. So v squared, we are looking for that v. We don't know it is equal to u squared, which is 0, plus 2a. Now, you know the acceleration is positive of g. So this is 9.8 times s, which is what? 39.2. So that means the v squared will be equal to 2 times, because here is 0, 2 times 9.8 times 39.2. So let's do that. 2 times 9.8 times 39.2. So let's go on. So we have 2 multiplying 9.8, 2 times 9.8 times 39.2. So that will give me v squared is equal to 768.32. So to get v, I'll have to take square root of both sides, which is square root of 768.32. So square root of 768.32. I took double square root, which is 27.71. So that means that our velocity is equal to 27.718, of which I can approximate that to 27.72 meters per second. So let's go back to our options and see which of them matches our answer. So moving on, let's see which of these options match our answer. So the answer is E, 27.7 meters per second. Very wonderful. So moving on, question 8. Question 8 seems interesting. So let's also pick question 8. Now question 8 says that two particles X and Y starting from rest cover the same distance. So two particles X and Y, right, starting from rest cover the same distance. So let's say particle X, let's write particle X here, and then particle Y here. They start from rest, so u for X is 0, u for particle Y is also 0. They both start from rest. Now the acceleration of X, right, is twice that of Y. So this one is twice, 2 times the acceleration of Y. The acceleration of Y is just its acceleration. So acceleration of Y is the acceleration of Y. Now, they now told us to find the ratio of the time taken by X to that taken by Y. Okay. Now, looking at this, is there an equation that is coming to mind? Is there an equation coming to mind? Yes, I can think of one. S is equal to ut plus half at squared. S is equal to ut plus half at squared. Right. So they said two particles starting from right. Yes, because they told us that they cover the same distance. That means distance for X is equal to the distance for Y. So S, T, U, and A. S, T, U, and A, correct. So that's the right equation to use. So now means let's get distance traveled by S. Now let's get the distance traveled by X. Distance traveled by X is going to be now u for X is 0. In fact, for both of them is 0. So you'll be left with half AX times T for X squared. Then distance covered by particle Y, right? Distance covered by particle Y will be half, because u2 is 0 for Y. Acceleration of Y times time for Y all squared. So this now gives me something I can use. I can say distance covered by X over distance covered by Y. What will it give me? Half acceleration of X time for X all squared divided by half acceleration of Y time for Y all squared. But don't forget something. They told us that the acceleration of X is twice that of Y. Are you seeing that here? The acceleration of X is twice that of Y. So I'll go, this will not give me, normally half will cancel half. The acceleration of X is twice that of Y. So that means Acceleration of x is twice that of y times time of x all squared divided by acceleration of y times time of y all squared. So acceleration of y cancels acceleration of y. Yes, so acceleration of x. Now normally since they travel the same distance, that means if the first distance is 50, second one will be 50. So 50 over 50 will give me 1. So that means right here I have 1 all along. So that will now give me 1 over 1, which is 1, is equal to 2 times the time of x, 2 times time of x squared over time of y squared. But remember, what they asked us is the ratio of the time taken by x to that taken by y. So what will I do? I can cross multiply. No, do I need to cross multiply? No, I will not cross multiply. I will not cross multiply rather. So what I'll do is to divide both sides by 2 so that time will be on one side. So that means time taken by x, or let's write it as it is so there's no confusion. So what that means is that 1 over 2 is equal to time taken by x squared over time taken by y squared. If you look at it in the answer, in terms of the answer, the answers are having roots. So that means we will not press calculator for this. So what we'll do is that since both of them have square, to take away the square, take square root of both sides. Square root of both sides, we take away their squares. So I have time of x over time of y is equal to square root of 1 over 2. And you know, from the rule of sword, if you have square root of 1 over 2, you can break it into square root of 1 over square root of 2, of which square root of 1 is 1 over square root of 2 is root 2. Now, normally we should rationalize, but I'm saying it already here. The answer is 1 over root 2. But let me just do it here. Now, square root of 1, like I said, is 1, and square root of 2 is root 2. So that will now give me time of x ratio time of y. So the time of x ratio time of y is what? 1 over root 2. All right, so let's move on. Like I said, we'll not be solving all the questions. We'll just be solving relevant questions. Then the rest, you can do them as practice. Then if there's anyone you find difficult, you could, of course, reach out to me. Now, the next one is, let's do question 10. Question 10 says, a mango fruit drops from a branch 10 meters above the ground. I like to draw sometimes. So let's draw. But the funniest is that I'm not a good artist. All right, so this is probably not a mango tree. So this is a hypothetical tree. It says a mango fruit drops from a branch 10 meters above the ground. So let's say this is 10 meters above the ground. So 10 meters above the ground, right? Now, let's draw our mango in blue. Dear mango, falling down. This is our mango falling down, covering that distance of 10 meters. Now, just before hitting his ground, his velocity is dash. That means the distance is going to cover is 10 meters. That one is already certain. The distance that it's going to cover is 10 meters, okay? So that means since it is falling from a branch, that means initially it was at rest because the mango was on the branch of the tree before it now decided to fall. And now, since distance from that branch to the floor is 10 meters, nothing is stopping it like the other question. So the distance to cover is what? Is 10 meters. So the distance that it will cover is what? Is 10 meters. So the now told us to find its velocity on hitting the ground. What are we going to do? What contains v? And now, since it is falling down freely, it is having acceleration due to gravity. And when you are falling down, your acceleration is positive, 9.8. So which equation contains all these things? We have v, u, s, and a. That's v squared is equal to u squared plus 2as. So v squared, we don't know, is equal to u squared, that's 0 squared, plus 2 times 9.8 times 10 times 10. To make my work easier, once you see a decimal point and you're multiplying by something that has 0, the number of zeros will move the decimal point. Like here is 1, 0, 1, 0, so it will move decimal point once. So I'll now have v squared is equal to 2 times 9.8. You can now do that one in your calculator. Sorry, 2 times 98, I beg your pardon. 2 times 98. So let's do 2 times 98. Normally, well, you can get it to. So v squared is equal to 196 of which to get v, you take square root of both sides. So square root of 196. What should the square root of 196 give us? Let's check. I think that should be 14. Is it 14? 2 times 98, right? Okay. Okay, sorry. I made a mistake. They said acceleration is 10. As you can see, they said acceleration is 10. So we're not using 9.8 for the acceleration. Please always use what is given. Now, if you check what is given, they said acceleration is 10. So that means I'll have to use 10 for acceleration all around. I'll have to use 10. So 2as becomes 2 times 10 times 10, which should give me 2 times 100, which should give me 200. So here will now be square root of 200. Now let's do the square root of 200. Square root of 200. Square root of 200. What does it give me? 14.1421. So that's 14. V is equal to 14.1421. So let's see which of the options match our answer. 14.1421. Which of the options match our answer? Well, okay, unfortunately for us, or should I even say fortunately, it is not something that they want in decimal, so that's even all good for us. So what to do is that you've learned solved from mathematics, right? Now, like they say, mathematics is the mother of science, so we're doing mathematics here. So square root of 200, that means I have to look for a number that I can get out of this root, and that number is 100. This is the same thing as saying square root of 2 times square root of 100, right? So this will now give me square root of 2 is square root. We'll leave it as square root of 2 because we don't know the perfect square root. But we know the perfect square root of 100, which is what? 10. So that's 10 times this root 2. So the velocity will be 10 times root 2, which is option A. Now, next question, question 11, is a theoretical question, but it's quite confusing for some students. So let's analyze it together. Question 11 says, which of the following statement is true of a body which is moving in a straight line with uniform acceleration? A says the velocity of the body is also uniform. Now, is it true that the velocity of the body is also uniform? No. If the velocity is uniform, remember, acceleration is change in velocity over time. If velocity is uniform, that means it is not changing. Change in velocity will be 0 over time. So that means the acceleration should be 0. Uniform velocity means that what? Acceleration is 0. So the velocity of the body cannot be uniform. So that's option A is out. Option B says must always be 0 when the body stops accelerating. That's not true. A body decelerates, how would I put it, gradually. Like when you're in a bus and the bus is slowing down, it's decelerating, but the velocity is not yet 0. It is decelerating, that's slowing down before finally becoming 0. So B is also wrong. C says we increase with time in the direction of the acceleration. Now, that's even the correct answer, but I always advise people to read through all the options just in case there's one final trick they want to play. Because acceleration is changing velocity over time, right? So that means if your body is moving with uniform acceleration, that means the rate of change of velocity is going to be in the proportion of the what? Of the acceleration. Because the acceleration is uniform. That means it is increasing at a constant rate, right? So that means the change in velocity will increase in that same uniform manner because the acceleration is what? Is uniform. I get it. But let's see. D says is equal to the quotient of distance traveled and time. Quotient of distance traveled and time. Now, distance over time, this is the quotient of it. That's you're dividing. Distance over time, what is that giving us? Distance over time is speed. It is not acceleration. So option D too is wrong. Then E says is the product of distance traveled times time. Now physically there's no quantity that is distance times time, right? There's no quantity like that. So that means E is also wrong. So of course we are correct to pick C. Next question is question 12 says a train has an initial velocity of 44 meters per second. Initial velocity is given to us as 44 meters per second, and an acceleration of 4 meters per second. An acceleration of 4 meters per second. Its velocity after 10 seconds is dash. So we're looking for the velocity, but we're giving the time. Now this is very, very easy. Super, super easy. In fact, you can pause the video now and try it on your own. You can pause the video and try it on your own. Now I'm going to be solving. Just pause the video and try it on your own. So the equation is V is equal to U plus AT. V, I do not know. U is 44 plus A is 4 times T, which is 10. So that will now be velocity is 44 plus 40. So that will now be velocity is equal to 44 plus 40 is 84 meters per second. Now, something is wrong here. Something is wrong here. Okay, I think I ignored the sign because now I think this is negative. The acceleration here should be negative. Now, why is the acceleration negative? Now, negative acceleration is showing that it is slowing down, that it is a deceleration. So V is U plus AT, correct, plus A here, as you can see, is negative 4. Negative 4 times time. What is the time that we got? 4, that's 10. So it will be plus times minus is minus. So 4 times 10 is 40. So 44 minus 40 is going to give me 4 meters per second. Now this velocity reducing is a proof that indeed the question is well structured. Because if you look at it, they said the acceleration is negative, right? Which means it is slowing down. Now if it's starting with 44 and then its velocity reduced to 4. Now that's why you can see that in the option, in question 11, we're correct to say that, where is that option? Option B is wrong because B says the velocity must always be 0 when the body stops accelerating, which is not true. Like in this case, the body stops accelerating and was decelerating. That's the meaning of this minus, that it is slowing down, right? It was decelerating, but the velocity did not become 0 immediately. It was slowing down gradually. So the answer here is 4 meters per second. Sorry, not 4 meters per second squared. It's 4 meters per second because this is just velocity. Now this is just velocity. Okay. Now, which one are we going for? Now, question 13. Let's look at question 13. Question 13 says that the distance traveled by a particle starting from rest, is plotted against the square of the time. Distance is plotted against the square of the time. This looks like those old pattern of jam questions, analytical questions. Now, they said it is plotted against the square of the time elapsed from the commencement of motion. The resulting graph is linear. So the slope of this graph is a measure of that. So they said the resulting graph is linear. What would the slope be? If I have S over T squared, that slope, slope is changing Y, which is S over changing X, which is T squared. But unfortunately, we don't know any value that is S over what? Over T squared, right? There's no physical quantity. So what will I do? I'll go to the equation of motion. S is equal to ut plus half at squared. Now we'll look at it. They said distance traveled by a particle starting from rest. So u is 0. 0 times t is out. So S is equal to half at squared. 0 times t is out because 0 times anything is 0. So they plotted S against what? Against t squared. That means, comparing with the equation of a straight line, which is y is equal to mx plus c. S is y. That's why, okay, now it makes sense. That's why S is on the what? Y-axis. And then if you look at X, now that means the intercept here is 0. That's why it went through this origin. Though I did not know initially, I just plotted it. But that means this graph will pass through 0 as the intercept. So intercept is 0. If you check it, X is T squared. That's why it's on the X-axis. So what will be the acceleration? What will be the slope, which is M? It will be half A, or the half of the acceleration. So the answer for that question 13 is D, which is half of the acceleration. Moving on, I think these theoretical questions are now easy. Moving on, Question 14 says, which of the following types of motion are oscillatory? Oscillatory motion are motions that are what? Vibratory, right? To and fro motion. They are to and fro motion. Now, which of the following types of motion are what? Are oscillatory? I says a diving board when used by a diver. That's oscillatory because when the person, this is like a diving board. If you are a diving board is used, I think you do in Olympics, for example, when you want to jump off of it into a pool. Let's say this is a pool of water. I'm supposed to use blue for water. You're trying to jump into a pool of water. But this is not visual. No need for me to keep painting. So as you bounce on it and you jump off, the diving board is going to vibrate. Are you getting me? As you bounce on it and jump off, the diving board is going to vibrate. So it's an example of oscillatory motion. II says the motion of the balance wheel of a watch. The balance wheel of a watch rotates, yes. Because that's why, though that's not the topic we're dealing with, under expansion, one of the disadvantages of expansion is the balance wheel of a watch. So the balance wheel of a watch actually does what? Actually carries out vibratory motion or oscillatory motion. III says the motion of the turntable of a record player. The turntable is a circular disc. So if you look at the motion is not vibratory. Instead, it is what? It is rotational motion. It's rotating. That your disc. So it's rotating. So it's not vibratory. Then the motion of the center of a 10 kobo piece as it rolls down an inclined plane. Same thing, it is rotation at the center of the 10 kobo piece. That's your coin. As the coin is rolling, the center is exhibiting what? Rotational motion. So it's not vibratory. Then V says the motion of a needle of a DC ammeter into which low current is passed. Now, we've not done that topic, right? Now, that topic is at the end, but definitely the motion is not what? The motion is not oscillatory. So the answer to this particular question will be, oh wait, yes, the answer should be we have I, right? Like I said, for the I, diving off a board is oscillatory, right? Because the board will vibrate. The balance wheel of a watch rotates back and forth mechanically, around the fixed center in order to keep track of time. That's oscillatory. The motion of a turntable of a record player, like I said, is what? Rotational. Then the motion of a center of a 10 kobo piece. Well, we can't call it rotational, but it is certainly not oscillatory. You can call it translational. Then the motion of a needle, yes, that's where I was looking at. That the motion of a needle into which a low AC current is passed is actually oscillatory. Because that needle, though we've not got into that topic, but that needle will attempt to be tracking this change. DC is direct current, AC is alternating. Alternating means it's not, it's going up and down, up and down, up and down sinusoidally. That means it's like a sine curve, up and down, up and down, up and down, unlike direct, that is single line. So the needle will be trying to track this up and down, up and down, up and down current. So the answer is actually going to be I, and then V, because V also is oscillating. So I, and V is option D. So the answer to question 14 is actually now option D. I think from now we can leave, or we solved every type of question under linear motion. Okay, now let's look at question 17. Question 17 says that two objects, one having 3 times the mass of the other. So this is object 1 of M1, and this is object 2. Let me say object 2 is 3 times of object 1, which is M1. They are dropped at the same time from a tall building. When they are dropped, the two bodies will have the same dash. Now, what would they have? The same acceleration. Because when you are dropping freely, what do you have? You have acceleration due to gravity, which is plus, whether 9.8 or 10, whatever you are given. So the answer is just simply what? Acceleration. Now, question 18 says that a ball, now, next thing we're going to move on is projectile motion. Question 18 says a ball is thrown vertically into the air. Vertically, it is thrown into the air, right? With an initial velocity, that means we're going to move on to projectile motion. So this is a ball thrown, but not now. We'll take it gradually. So this is a ball thrown into the air. That means initially it was thrown with a velocity, right? Because this one is not at rest. This one is that from the beginning you threw it already. So it has a velocity, which we don't know. Then to reach a height. At the height, maximum height, when you throw something to get to a point before it starts falling down. So at the maximum height to reach it, final velocity will be zero. That's why when you throw something, it look as though it will momentarily pause before it starts falling down. So at that maximum height, final velocity is what? Is zero. Then what will its acceleration be? Now, because you are throwing it upward, its acceleration will be reducing till it gets to that 0 point, till it gets to where its velocity is zero. Remember, I told you deceleration does not mean the velocity will immediately be zero. That means your object will be going up till, that means it will be reducing because it's going against gravity. Gravity acts downward. So as you're throwing your object upwards, gravity is pulling it downward, reducing its acceleration. So little by little, this initial velocity you started with will be reducing till it gets to that maximum height where it is zero, and then it falls down. So its acceleration will be negative. Now, like I said, write everything you are doing because you can now begin to see something. Now, for what I'm saying, maximum height, right, which is the highest height, and that was the question asked us. They said, what is the greatest height reach? We don't know. But we know that at that point, it was going with a velocity. We don't know it. We'll still call it u. At the maximum height, final velocity is zero because that's why the body stopped and then started falling down. Then we now know that the acceleration is negative because it is going up. And that's why it was reducing and reducing till it got its acceleration to zero. So what are we now going to do? What are we now going to do? Or which equation are we now going to use? And we're looking for the greatest height to be what? To be reached. And that height is S, right? That height is S under the equation of motion. I just called it height. So I can say V squared is equal to U squared plus 2AS. Yes, V squared is equal to U squared plus 2AS. It contains all the parameters V, U, S, and A. Yes, contains all of them. Now, V squared is 0. U, we don't know it. Then plus 2. What is A? Minus of G. Because it is going up, which is against G. So that's why it will be reducing. Then times the maximum height reach, which you don't know. Right? So plus times minus is minus. So that means 0 is equal to U squared minus, because plus times minus is minus, and 2 times G times S. 2 times G times S. So moving this to the other side, we now have 2GS is equal to U squared. So from here, S is equal to U squared over 2G. So S is equal to U squared over 2G, which is option D. Now, moving on to projectile motion, this will not be U squared, will not be U squared or U squared sine, because when you project it with an angle, it's not be U squared sine squared theta over 2G. And that's how those equations were derived. But it is believed you have done them at O level. But if you have probably forgotten, this is like a reminder. So the greatest height reach will be U squared over what? Over 2G. Now moving on. Let's see another one. Question 23 says, which of the following graphs represents the motion of a body with uniform velocity? Uniform velocity means unchanging, right? Like I told you. So which of them shows unchanging? Now the first one is showing decreasing. The velocity is decreasing. The first graph, let me draw it. If you look at the slope, it's sloping downward, which means it is decreasing. The second one is showing a steady acceleration. The third one too is showing an acceleration, though quite slow. It is quite slow, right? But it's like 0, it came down, then started increasing. But the one that is uniform is D, just uniform. So the answer is D. Question 24 is also something that is easy. I believe you should be able to solve question 24 because by now I've given you everything that is required. But let's do that one. Question 24. Then we'll move to another topic. Question 24 says a car moving with a speed of 90 kilometers per hour. That means the speed is 90 kilometers per hour. Now, always be careful of your units too, because I'm saying kilometers per hour. Was uniformly brought to rest by application of the brakes in 10 seconds. Now, you see, time is in seconds. They gave us 10 seconds. So here cannot be in seconds and here be in hours. So what will I do? Let me convert my kilometer by hour to meter per second. Why am I even doing that? Because number one, the time here is in seconds. And if you look at the answer, wait, come to think of it. The answers are in meters, meters, meters. This one is in kilometer. Anyways, we'll convert it to meter to be safe. If there's a need for us to convert it to kilometer back, we'll convert it back to kilometer. So 90 kilometers per hour means 90 kilometers per, which is over hour. Now 90 kilometers to convert it to meter means 90 times 1 kilometer is containing 1,000 meter. Over 1 hour is 60 seconds by 60 minutes. 60 seconds, 60 minutes, which make up 1 hour. So that's 60 into 60. So doing that will now give me 0, 0, cancel 0, 0. Can anything go here? I'll now have 9 times 10 is 90 over 36. No, it's not 90. Here it's still 90, right? Nothing cancelled its own 0. So 90 times 10 is 900 over 36. So let's calculate that. 900 over 36. 900 divided by 36 is 25. So that means use 25 meters per second. 25 meters per second. So we can go on to solve. We've converted it to the appropriate units that can be used here, which is 25 meters per second. So we have 25 meters per second. Then where were we? It's brought to rest in 10 seconds. That's question 24, please. 24 here. So time is 10 seconds. So how far did the car travel? That means we're looking for distance. How far is distance before the brakes were applied? So who sees what we are to use here? Who sees it? We have S. Now, from definition of speed, like I told you, there's a fourth equation of motion which is not commonly used, right? Average speed is total distance all over total time taken, right? Average speed. Now, what is average speed? Average speed is what? Basically, the average of the speed, which is the first one, which is initial velocity times final velocity divided by 2. This is the average. This is how you take mean. Summation of all the values over total number of values. So we have initial and final. So average speed is equal to distance over time. So that means if I'm to make distance a subject, just cross multiply only the time. S will be equal to U plus V over 2 times what? Times T. So this equation can be modified to give you S is equal to UT plus half AT squared by just substituting V is equal to U plus AT. But anyways, in JAM, you're not proving, right? You're not proving. So basically, this is the formula we need, and that's what I just wanted to show us. That the speed, average speed is total distance over time. So from here, we can get the distance as average speed times time. Now, why am I doing it? Because everything I need is in this formula. S, T, U, and then V. Well, there's no V. There's no V. Okay, they said it was brought to rest. Brought to rest means finally it came to rest. So that means its final velocity is 0. So there's V. Yes, there's V. So the how far is now given by U, which is 25, plus V. V is 0, so we leave it, times T. What is T? 10 seconds. So 2 here, 1, 2 here, 5. So 5 times 25 should give me 125. So how far to cover is what? 125 meters. Now, next question is what question is that? Question 25. Let's take question 25. It looks like an interesting one. Now, question 25 says, what is the average velocity of the sprinter whose velocity time graph is shown in the figure above? So they said, what is the average velocity? Now, average velocity, we can use it as average speed too. Average velocity is total distance all over total time taken. All over total time taken. Now, how do I get total distance? Now, for your velocity time graph, I told you the area of the shape is the area or the total distance covered, right? I believe I mentioned that the area of the shape is the total distance covered. And the slope depends, like for velocity time graph, the slope will be change in y, which is velocity, over change in x, which is time. So velocity over time is acceleration. So the slope of a velocity time graph shows acceleration. Then the slope of a distance time graph, distance will be here over time. And what is distance over time? It is what speed. So the slope of a distance time graph will show speed. But that's not what we're asked here. They said, what is the average velocity? So average velocity is total distance over total time. Now, what is total distance? Like I said, total distance here is what? Is the area under the shape. Because the area under the shape will show you in my acceleration, in my constant speed, right? In my deceleration, what are the total distance I cover? That's what will be under the graph. So that means we have to find the area of this shape, which is a trapezium. Now, area of a trapezium. Now, here is 2, right? Here is 6, and here is 10. Then here is 10. Here is 10. So area of a trapezium is, if you have a trapezium like this, is half A plus B times height. That's half sum of parallel side, which I call A plus B, then times the height. So A plus B times how high it is will give me the distance. So let's apply it to that question. Half sum of parallel sides. So that's half, sum of parallel sides. So sum of parallel sides. Now from here to here, if you trace it, that here is 2, here is 4. So that means from 2 to 4 is, from 2 to 6 is 4, rather. My mind is just going fast. From 2 to 6 is 4, because here to here is like a rectangle. So it is the same with here to here, which is 2 to 6, which is 4. So A, it will be 4. Then plus B, here is from 0. Yes, here is 0. So here is from 0 to 10. So A plus B now will be 10 times height. How high it is what? If you look at it, is 10 times 10. So it will be 2 here 1, 2 here 5. This will be 14 times 5. So the distance, which is the area of that graph, will be what? 70. It will be 70. Is it 70? Yes, it will be 70. I hope we got it correctly. Okay, wait. I just saying, no, we didn't get it correctly because I did not plot the correct points. Because here is 4, 6, here is 8, not 6, and then 10. So that means from A, the A, which is the top side, here to here, which is from 2 to 8, is actually 6. Is actually 6. Are you getting it? From here to here is actually what? Is actually 6. Then from here to here is 10. So that means the distance covered, which is the area of that graph. So the distance covered, which is going to be the area of the graph, will be half sum of parallel side A, which is 6, plus B, which is this full side, which is 10, times the height. How high it is, if you check it, is what? 10. So 2 here 1, 2 here 5. So S is now going to be 16 times 5. And that should give me 80 meters. So the total distance covered as shown by our graph is what? Is 80 meters. But then we're told to find average velocity. Like I said, average speed is equal to total distance over total time taken. Distance over total time taken. So average speed, which is same thing as average velocity, only that velocity has direction because velocity is now vector. So we can use the formula for average speed for the velocity because they will have the same magnitude. So it's going to be total distance, which is 80 over what is the total time? If you look at the total time, it's 10. From 0 to 10 is the total time. So that means total time is 10. So looking at it, the average speed for question 25 should be what? 8 meters per second. Now, there's no correct option there. I'm saying 85, I'm saying 17, I'm saying 8.5 and 1.7. So none of the options there are correct. Every option there is wrong. Every option there is wrong. Except maybe there was a typo. So that's option there. None of them is correct. Now, let's look at question 20, 26. Now, 26 is interesting, but like personally, I don't think that there's some of these questions that normally, as a tutor, you'll be able to know that they can be based on the time frame and the number of questions being answered. Some of these questions are not the kind of questions that they ask in JAM, like they're no longer JAM style, but I feel it is important for us to study them, at least for analytical reasoning, and basically you're writing JAM to get into a tertiary institution which would solve questions like this. So it's best you still practice them. So question 26, it will be a bit longer, just a bit. It says that a small metal ball is thrown vertically upward. So let's say this is someone on the ground. This is, let's say, Chibuzo. I hope there's nobody behind Chibuzo that will listen to this. So this is Chibuzo. So Chibuzo, what is Chibuzo doing? Now this is Chibuzo, right? So he throws a ball vertically. No, yes, vertical, yes, horizontal. So he throws it vertically. That means along the vertical. He throws it vertically upwards according to 26. Remember, I'm on 26. With an initial velocity of 20 meters per second. With an initial velocity of 20 meters per second. So his initial velocity is 20 meters per second. He throws it vertically upward from the top of a tower. So that's him on the top of the tower. Let's draw the tower. That means he's not on the ground. He throws it from the top of a tower. So here is a tower. I wonder why I drew him on the edge. So he throws it from the top of a tower, right? With an initial velocity of 20 meters per second. If the ball took 6 seconds to reach the ground, that means from here to the ground. Let's draw the ground here. Though this is not a tower if it's not that tall. Total time taken was 6 seconds. So total time taken was 6 seconds. Determine the height of the tower. So I told to determine the height of the tower. Now I'm going to break this distance or this journey into what? Into different stages, right? So total time that it took for this ball to be thrown upwards and then get to the ground was 6 meters per second. Was 6 seconds. So let's, like I said, break this. Now from the top of the tower to maximum height, that means let me use a different color of pen. Let me use green. Now I'm going to break it from when he threw it to when he got to the maximum height. I'll call it stage 1. So for stage 1, now in stage 1, what did he do? He threw the ball, it got to maximum height, right? Remember, when he threw something to get to a particular height before it starts falling down, that height is called maximum height, right? So from here to stage 1, what happened is that he threw it upwards. So the initial velocity is 20. Final velocity, final velocity will be 0 because at that maximum height, the final velocity will be 0. The body will stop moving at that maximum height. That means the acceleration, has been finally depleted, and then the velocity will now be 0. Then it will now start falling back with a positive acceleration. So the final velocity will be what? Will be 0, and the acceleration will be negative because, like I said, it's going against gravity, right? So we don't know the time. Let's call it time. We don't know the time. We don't know the time, actually. We don't know the time. So let's just call it T1. We don't know the time. Now, is there anything I can do to get the time? Yes. I'm seeing V. The green pen looks faint, so let's go back to the other one. I'm seeing V. Now this one too is faint. Let's go back to the other one. I'm saying V is equal to U plus AT. Now V is 0 is equal to U, which is 20. That's for first stage. Then plus A, which is minus G. And what did they give us as G? They told us that G is 10. So let's use 10. Let's use it straight away. 10 times time. I don't know the time. But they told us total time for this body to reach the ground was what? Was 4 seconds. So 0 is equal to 20. Plus times minus is minus. Minus. Then 10 times T is 10T. So if I take 10T to the other side, it will now be minus 10T to the other side. It will now be 10T is equal to 20. And to get t, I divide both sides by 10. So t will be equal to 2. So that means the time taken for this metal ball to be thrown and get to this maximum height is 2 seconds. But remember, total time taken to get to the ground is 6. So that means let's now do stage 2 of the motion. Stage 2, which is where the body now begins to fall. So from stage 2, what will now be the initial velocity? Please take note of, because now it is continuing from this first stage where you go to that final height, then it will now start dropping. So that means initial velocity is going to be 0, because at that point it is starting from rest. Initial velocity will be 0 for stage 2. The acceleration will be positive because from this point now it will now start falling down. So that means the acceleration is going to be what? Is going to be positive of g, which is 10 meters per second. I'm not writing the units because this is jump. If you are writing y, please write units. If you have this, that's even if you have the space to fill in all those parameters. So write units, but in the final answer, you must write units, please. So for the second stage, the acceleration will be t. It will be positive. Then the time will be the remaining time. If the total time to reach the ground is 6, and it took 2 seconds to get to maximum height, from maximum height to the ground will be what? Will be 4 seconds. But what did they even say we should find? We must keep that in mind. They said we should determine the height of the tower. So that means we're looking for the height of the what? Of the tower. But anyways, now, the height of the tower, are you getting me? Okay, let me not jump into that first. Are we getting? So let me not jump into that first. Now, in the first stage, we got the t as what? As 2. As 2 years, as 2 seconds. We can also get the distance covered. Are you getting it? We can also get the distance covered during the first stage. I think that's what we will also do. We need to get the distance covered. That means when he threw the ball, let me explain that very well. When he threw the ball from the top to this place, what distance did he cover? Are you getting me? That means this height here. So what can we use to even get it? We can use v squared is equal to u squared plus 2as. Looking at it, v squared is here. We know v. U, we know u. A, we know A. Then we can get S, yes. We can get S for first stage. Let me put it by the side here. For first stage, let's get the distance too. So v squared is equal to u squared plus 2as. So v squared, what is the 5? For the first stage, remember, is when it got to maximum height. So at maximum height, v is 0, u is 20 squared plus 2 times a is minus 10, then times s. We don't know the s. So 0 will be equal to 400 minus 20s. If you take minus 20s to the other side, to become 20s is equal to 400. And if you divide, 0 cancels 0. 2 cancel here is 20. So the distance in the first stage is 20 meters. So that means when the person threw the ball upwards, it covered the distance of 20 meters to get to the maximum height. Then we need to know the remaining what? We need to know the remaining distance down. So coming back to stage 2, after getting the time as 4 seconds, what will be the distance? We don't know the distance. So straight away, we're not looking for anything, it's just the distance. So what can I use to get the distance for stage 2? I can call it distance 2. So distance 2 is going to be ut, right? U is here, t is here, a is here, yes. So st is going to be ut plus half at squared, which is going to be like, remember the u is 0 because now the second stage is from maximum height, which means that's gone to that maximum height and that's where it's starting from. So that means the initial velocity is 0. So 0 times t is out. So now I have half times. Now since it is falling down, acceleration is positive and the time is 4 squared times. Let me put my times. So it's going to be 2 here is 5 times 4 squared is 16. And 5 times 16 will give me 90 meters. So the distance in the second stage is 90 meters. In the first stage is what? 20 meters. But they told us to look for the height of the tower. Are we getting it? They told us to look for the height of the tower. Wait, where was I? Yes, this should be 80, sorry, not 90. So here should be 80. All right, so the distance in the second stage is 80. But then the question will now be, how do I find the height of the tower? Now we have to do that visualization. Now the height of the tower will be, watch, it will be this 80 minus the first one. Why? Because the first one is distance from here to here, which is 20. Are you getting me? The second one is the distance from this maximum height. Let's draw it outside, from the maximum height down to the ground. Now don't forget, this distance is still there because it will still cover the distance from maximum height to where it was thrown from, which is here. So if year to year was 20, that means year to year is 20. The height of the tower, which is what we're looking for, will be from the base down. So if the total height from the maximum height here to the base down here is 80 meters. So to now get the height of the tower, it will be the 80 minus the 20, because this 20 is from maximum height to the top of the tower where it was thrown from. I hope you understand. So this 20 is, for the first stage, it is the distance from where it was thrown from to the maximum height. So to get the height of the tower, it will be the total 80 in the second stage, which is from maximum height down, minus this 20. And that will give me 70, 80 minus 20 is 60 meters rather, which is option A. So the answer to question 26 is what? Is option A. So I think that with this, we will be able to solve any question under what? Under linear motion. Under linear motion. So we'll go to a new topic, which is projectile motion. The other questions here are on projectile motion. The other question here are on projectile motion. Okay, let me do 27. 27 is the last one. Then from there, we'll now start. Let me do 27. Or you could try 27. 27 and 28. Probably before I start the next topic, I would go on to it. You could try it. 27 and 28. Okay, let me do it. Let me do 27. Though the question is not common, but it's simple. It's simple. 27 says the body starts from rest, so U is 0, starts from rest. Move with uniform acceleration of 6 meters per second squared. What distance does it travel in the third second? Wow, this is quite direct, straight to the point, like sharp, 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 sharp. So what do we do? What can we use to solve this 27? We can use S. We're looking for distance, right? S is equal to UT plus half AT squared. But why? Why UT? Because time is given to this. So what distance does it travel in the third seconds? In the third second. Now, the distance traveled in the third seconds is different from what distance does it travel in 3 seconds. Because in 3 seconds means from 0 to 3. In the third seconds means maybe 0, you have 1, and you have 2. In the third second means just within the third second, which means from 2 down to the 3. So now the idea will be to get the distance in 3 seconds, you use T as 3. To get the distance in the third second, just in the instance of the third second, that means from 2 to the third second, it's just going to be distance covered in 3 seconds minus distance covered in 2 seconds. That's what will give us the time fraction in the third seconds. Do you understand? Let me do that again. Distance covered in 3 seconds means from 0 to 3. That's total time is 3. So total distance covered in 3 seconds goes. But distance covered in third second, in third second, that means from 2, you just need 1 more second to enter 3. So that means you're looking for the distance covered in that extra 1 second that gave you the third second. So it's going to be distance covered in 3 seconds minus distance covered in 2 seconds. So moving on, we have to get distance covered in 3 seconds. So S is equal to, U is out because U is 0, so there's no point. So the equation will now be half AT squared. So S is equal to, in 3 seconds, half times what is A? 6 times 3 squared, which is 9. So 2 here 1, 2 here 3. So distance in 3 seconds, let me write it. Distance in 3 seconds is going to be 3 times 9, which is 27. Minus distance in 2 seconds. Now we have established that normally is starting from rest, right? So normally initial velocity is going to be half at squared. So distance in 2 seconds is half times 6 times 2 square, which is 4. 2 here 1, 2 here 3. So distance in 2 seconds will be 3 times 4, which is what? 12. So distance in third seconds will be 24 minus 12, which is going to be 15 meters. So the answer for 27 is 15 meters. All right. So 28 is still on projectile motion. So that's all about this particular topic. So we're moving on to another topic, which is what? Which is projectile motion.